All right, we are back with lottery, and in this one, our main focus is going to be creating the driver that kind of simulates our lottery. The idea is that we're going to create a winning ticket, and then we're going to keep making lottery tickets until we get a winner, and we'll basically count how many it takes in order to do that. But first, let's kind of take a look at what we have done so far. So I'm in IntelliJ, I'm in my lottery ticket object class. The main concept here, the main new concept that we're kind of practicing and trying to integrate is that we can have an array as an instance variable. Here I see nums. It is an integer array, and it is inside the lottery ticket class, right? Instance variables have an access modifier, in this case private, so this is like a property. Really is the main property of a lottery ticket. It's basically all a lottery ticket is an integer array. I then have this constructor that takes in a length. We have a precondition saying that length must be between 0 and 60. And effectively, we're going to make a lottery ticket with that many numbers. So length is number of numbers in the lottery ticket. Something like that. Right. So for instance, I believe in our driver, we made one with a length of 5. So this lottery ticket, as we're going to quickly see when we execute our program, is going to consist of 5 numbers. And these numbers are random in the range 1 to 59, inclusive on both ends. Okay. Not only are they random, they are unique. Right? I've got some comments here. I would consider turning this into a method. Not a big deal. Like, we're not using it in other spots per se. But if you ended up using this randoming technique in a different constructor, for instance, maybe it would be worth it to put this in a method. Why don't I quickly kind of show you what that would look like? Right, I'm going to basically take all of this and put it in a method. Like our contains method, it's going to be, I would consider it a helper method, right? Private. You could say void. Right. One approach to this is that it is just going to populate or fill nums no matter what. Right. And if I'm making that a helper method, private, I feel okay to do that. The other technique is that you actually create an integer array and return that. Right. So I'm going to create fill, and these comments look kind of weird because they ultimately would have been Java comments, right? So this is going to basically do this. I'm going to replace those with asterisks. And so this helper method, which you don't necessarily have to Java doc it because it is private, will fill the lottery ticket with numbers in the range 1 to 59. Numbers in nums are unique. I would maybe list this as a post condition. Okay. Again, all I'm doing is taking this stuff. I have cut it with Control X in Windows and pasting it here with Control V. So I've extracted this stuff and put it into a method. The idea is if you were to try to use it to kind of populate in a different lottery ticket object, a different lottery ticket constructor, I should say, then you have this code kind of encapsulated in a method that you can, or a function, whatever you want to call it, that you can use over and over and over again. Sorry, I've been doing a lot of JavaScript recently. So another advantage to it is that you could add in a parameter, some type of integer that maybe helps fluctuate this range as needed. Maybe you're doing a different lottery ticket and it can go up to 99 numbers, for instance. This very easily would allow you to kind of do that. So don't fall asleep on the method approach. It has a lot of advantages. Right? Maybe this is what we should have done to begin with. But what it does is we're going to basically loop through nums using a while loop. I'm going to random a number, and then if nums does not contain that random number, we'll insert it and then go to the next index because we have successfully generated a unique number. Now this contains method, as mentioned earlier, is a little helper method again. This code could very easily just be right here. Okay, Instead, I've extracted it and kind of, encapsulated it in this method, this helper method, to clean up the code. Right? Again, you would just basically have all of this inside of this, and what that would be is a loop inside of a loop, which is not necessarily wrong. It just can be a lot, right? Whereas this just simply is very sleek and kind of how it reads, as long as you know how to read it. If nums does not contain x, then we add it. We'll go to the next index so we don't override any old elements. In the event that I get a true value back, meaning that it's already there, we say not true, giving us a false value. We'd skip over the if statement. Most importantly, our index would not change, and we would effectively try again. We would random a number, see if it's in nums. If it's not, add it, go to the next one. If it is, stay on the same index and try again. All right? I've already talked about contains, and then lastly we have our toString, which is going to produce something that looks like this. So one last thing I need to do is that we wrote this fill method. Notice it's gray here in IntelliJ. That's because it's never actually used. Right? So my lottery ticket, we're going to basically initialize the integer array using the length. I then need to fill it. And it's that easy, right? Fill would get called and it would do the stuff that we were previously doing. I'm going to execute this again, and we're going to get another lottery ticket with a length of 5, but 5 different numbers, indicating that everything is working. So this is kind of the method approach to doing that. So we're going to pick up there. All right, the main focus today is actually going to be on the driver. We're going to create the winning lottery ticket. Now, I could generate random numbers, say that's the winner, and then go from there. When we're testing, you probably want a little bit more control than just going full out random. So one approach I would recommend is that we overload this constructor so that we can basically say what the winning lottery ticket is, which, by the way, is kind of how it happens, right? In an actual lottery, you have the option, I should say, of going in and saying, I want these numbers. All right, you can basically say what numbers that you want to play with and then go from there. So let's overload this constructor. I'm going to do public lottery ticket. And what's going to be different about this one is I don't really care about the length. Instead, what I'm going to do is I'm going to take in an integer array as a parameter. The idea is that we would specify all the numbers up front and then say, use these numbers for the lottery ticket. Okay? Effectively, the numbers are going to be specified in the driver, and so they would pass in, they would come in as an integer array that's already initialized. And what we're going to do is that we're going to take the instance variable and set it equal to the explicit parameter, the local variable. All right, I'm going to save nums into this. Hopefully, something that you're kind of recognizing is pointers. Right? I'm saying I want this object variable to point to this one. Okay? Effectively, so this is a local parameter. What it means is it's going to get created here whenever the constructor gets called. Right? Whenever the constructor gets called, we're going to create integer array nums and tell it to point to whatever integer array is being passed in. This variable stops existing here. What that means is it comes in, we tell our instance variable to point to it, and then the local one, this guy, goes away. It stops existing, right? But then this one still exists. This one will exist over the life of the object. So you still have a variable pointing at that integer array, right? So you still have a reference to it. This guy will go away. He's going to go away right here. He'll get Java garbage collected, right, and no longer exist. Not a big deal, but that's like more technically what's going on behind the scenes is pointers. I am telling this variable to point at what this one is. Okay, so that's basically it. We're going to take in an integer array, and now this one has the exact same values as this one. Let's actually see how that would operate. Right, I am back in my driver, And what I'm going to do is create the winning lottery tickets. Okay, so we want to create our winner. That's going to be a new lottery ticket. And what I want to do is pass in an entire integer array. There is syntax to create the integer array right here on the spot. It's kind of ugly. I don't recommend it. It's not part of the subset. So we need an integer array. Right, so let's create an integer array. I'm going to call it winning nums. You could just call it nums if you would like. And I'm going to use this initializer list, which is part of the subset and very clean, in order to give this thing values. Right? Let's do something like 5, 17, 4. I want to keep it simple, like 3 numbers. 2 would even maybe be respectable, because I want to test the program to make sure it works before I even try to tackle, 5, 6, 7 digit lottery tickets. Okay, so I'm going to create this integer array using an initializer list. I then want to pass it in here so that we call the constructor. We call this constructor. So I'm going to pass in winning nums. Okay. Again, calling back to the pointers, right? We create this integer array here. That is a new distinct object. I create this integer array variable and tell it to point to that object. Here, when I call the constructor, what I'm really doing is sending the pointer. What really happens is that this integer array, nums, gets created. It's a variable. That variable is told to point to the same thing that winning nums is pointing at, which is this guy. We then tell this dot nums to point to it. Right? So in that scope, in this scope, I actually have at this point 2 variables referencing this object. I have this guy here. I also have the instance variable that is referencing it. This guy got created and no longer exists. Okay, that was a little bit more detailed. I wasn't even planning on talking about that, but that's effectively what is happening with the pointers. I wouldn't worry too much about it. Our lottery ticket is going to now have these numbers inside of it. Right? What do I mean? Let's see it. So let's say system.println our winner, which is the winning lottery ticket. And I'm going to tell my program to run so we can see that. Okay, there it is. And again, I'm going through winner to see that. Okay, so we have what we're going to consider the winning lottery ticket. I'm actually ready to flesh out this driver. We're going to basically create lottery tickets over and over and over again until we get a winning one. Okay, there is, I could in theory go forever on this, particularly because it's random. So what I really am saying is that it's not a set amount of iterations. I don't know how many iterations. I'm going to go until I'm finished, until I'm done. So this kind of harkens to a while loop, right? So I actually recommend one that we did, a kind of a style, a technique that we did in a previous video. I'm going to create this flag. Right? This Boolean done, and initially it's false, and I'll say while we are not done. Okay, while we are not done, I'm going to cut this stuff with Control X. You can move it around, manipulate it however. While we are not done, we're going to create a lottery ticket. You can print that off if you would like. This will be probably pretty good for testing. However, printing does take a lot of time. Like displaying stuff to the console does take a lot of time. So this will slow down your program like drastically. Just FYI. So we have a lottery ticket. Right? I've got a winning lottery ticket. I need to know, does this lottery ticket match this one? Okay, what I really want to know is, are the numbers that are inside of these objects the same? What do we need? What we need is an equals method, right? We need an equals method to determine, are the 2 variables equivalent? Are the 2 lottery tickets equivalent? Doesn't matter where you're at in lottery ticket writing this, but we're going to write public Boolean equals. I'm going to compare ultimately 2 lottery tickets, which sounds like we're going to have 2 lottery ticket parameters, explicit parameters. But no, one of them is going to be an implicit parameter, and the other is going to come in as an explicit parameter. Okay, so we're going to return true if this lottery ticket has the same numbers in the same order as other. False otherwise. Right, return true if this lottery ticket has the same numbers in the same order as other. False otherwise. Okay, equals is going to compare two lottery tickets. I see one of them. Where's the other lottery ticket? The other lottery ticket is going to be this, the implicit parameter. Okay, let me show you what a call to this method would look like. We would say if our current lottery ticket, the one that I just created, is equal to our winner, then we have a winning lottery ticket. We have found a match. Right? This is what a call would look like. Right? Hopefully you've seen something similar before. We've used an equals method. We used it with strings. Right? We compared one string to another string. We were comparing the implicit parameter to the explicit parameter. The way that we refer to the explicit parameter is here. We'll call it other. And the way that we refer to the implicit parameter is going to be this. Okay, ultimately what I'm actually doing here is looping through nums. Okay, and we're going to make a comparison. We're going to compare each of the elements to say, are they the same? In theory, these things should have the exact same length. We could precondition that if you wanted to, right? We could precondition and say that the length of nums for this is the same as the length of nums for others, but it's actually a very easy check to just say if the lengths are different, we just stop. If the lengths of those arrays are different, there's no reason to even check to see is it a winning lottery ticket, right, if they're equal, because of course they're not going to be. So if this dot nums, right, that is the integer array inside of the implicit parameter, dot length, okay, this is a lottery ticket. I can go in that lottery ticket and get the integer array. So this dot nums is an integer array. I'm going to get the length of that, which is a single integer. I want to know if that integer is different from the length of the other one, right? So other is very clearly a lottery ticket. I'm going to go inside of it to get the integer array. I then want to know how long is that integer array. If the length of these two integer arrays are different, right? If they're not equal, we can just simply return false. There's no reason to continue. We would exit the method. Okay, something of note that kind of trips some students up here, I'm referencing nums. We tend to think that the instance variable is inside of the object and it is private, so how in the world can I access that? Well, I've been very particular with my language. Whenever we first talked about private, what I said is that it restricts access to the class that it is defined in. We are in that class, right? Other is a lottery ticket. I can pull nums directly out of other without an accessor method, even though it's private, because we are in that class. We are in the lottery ticket class. Okay, if we had an accessor, you could, of course, maybe go through that, but this is easy enough. If I'm still in the method, what that means is the lengths are the same, so I don't really have to worry about an index out of bounds. I'm going to use basically a for loop. Right? My shortcut syntax there was for I. It's giving me an opportunity to change the variable here. I don't want to do that. I am going to tab over, and we do want to stay in bounds, but effectively they both have the same length, so it doesn't matter which one you pick. Right? You could say this dot nums dot length. Of note, you don't have to say this dot because there's only one nums in this scope. Right? There's other dot nums, but in terms of nums, there's only one. It's the one that belongs to this. So you could leave it off. because it's simply implied. And I actually am going to do that here. All right, we're going to loop through nums. With each iteration, I'm going to ask, is the current element equal to the corresponding one out of other? More particularly, I want to know if they're not equal, because the moment that they're not equal, I can stop there. If the current element, that is nums at I, does not equal other.nums at I, right? Other is a lottery ticket. I'm going to go inside of it. I'm going to pull out nums. That is an array. Nums at I is a single integer. If nums at I does not equal other at nums at I, that means the elements are different. I can return false. I can stop right there. If I manage to go through the entire array, and this never happens, that means they all match. I can return true. So here's an equals method. This part, again, you could precondition it and not have to worry about it, right? You could assume that if we're calling this method, they have the same. Here, it's a simple check, so I did it. If we're still in the method, they must have the same lengths. So I go through and check to see if they match. More importantly, I check to see if they don't match, because the moment that they don't match, I can stop there and we're done. Why don't we quickly test the equals method, and then we'll worry about testing it in the loop. So I'm just going to grab all of this, hit Control / to comment it out. Right, we got a winning lottery ticket, and these are the numbers. I'm going to create another one, right? We'll do 5, 17, and 4. I'm going to do the same numbers. Notice that this is actually a different object. Right? I'm doing that on purpose. The other option is to say that test nums is equal to winning nums, which is when we're playing with pointers, and that can get real confusing when we're talking about, you know, two objects being the same. So I'm going to create a test lottery ticket using test numbers. So what I'd like you to see is that we have two completely different lottery ticket objects. Right? I'm using the new operator, using two completely different set of integer array variables, numbers, I should say. But I want to know, are they equal? Is test equal to our winner? I should get a true value out of this. True, they are the same. I'm not even looking at, you know, what test looks like, but they are the same. What if this number is something different? I should get a false value here. And lastly, what if they have different lengths? I should get a false value, but more importantly, it doesn't break, right? We exit the method first. If they had different lengths and I got down here, I would have a problem. We would potentially go out of bounds. Okay, so that works. I'm going to Control / to comment that out. So the equals method looks good. I'm going to highlight these lines, hit Control / to comment this stuff back in. We have our winning lottery ticket. Our equals method looks good. We're going to keep looping until we're done. With each iteration, I'm going to create a lottery ticket. It needs to have the same length as my winning lottery ticket. In this example, that's 3. We can print it off if we want. If the lottery ticket that I just randomly generated equals my winning lottery ticket, we found a winner. So we can maybe print off some type of winning message. Winter. I found a winner, so I can stop. And the way that we're going to stop is that we simply take done and set it to true. Okay, so what I'd like you to notice is done starts off as false. You say while not done. Well, done is false, so the opposite of false is true. This is true. We would enter the body of the while loop. We'd create a lottery ticket, print it off. We would see if they're equal. In the event that they are equal, we print off a winner. We set done to true. We'd come back up. We'll say while not done. Well, done is true. Not true would be false. I'd have a false value, meaning we would skip over the while loop. We would exit the while loop. Okay. In the event that this is false, right, the two lottery tickets aren't equal, we would skip over this body. I'd come back up. Done, never changed. It's still false. Not false is true. We would enter the body and do another iteration. So this will keep going until we get a winning lottery ticket. Yeah. So let's test this real fast. I'm using 3 numbers. That may be too many. I don't know. This thing can go pretty fast. In particular, this is going to maybe slow us down a little bit. And here we go. Right. This last little SOP shows me what the final lottery ticket was, and that is, of course, equal to my winner. Okay. An important thing to do here is going to be to count how many iterations we have, like how many times did we go through this. So I'm going to create integer I and set it to 0. Let's call this count. We're going to count how many lottery tickets we have. Right? Every time this executes, we're going to count it. Now, one of the kind of beautiful things about this technique is it doesn't actually matter where we do this count. Right? I could do it at the very beginning to make sure that we count it. You could actually do it down here. Because as you see, this is slightly different from like a return statement. If this were like a return statement in a method, we would exit and never actually reach this statement. Because this is just changing a value, this is just a simple if statement, even if this happens, right? Even if we find a winning lottery ticket, we're still going to count it. This still executes. Okay, I am probably going to be interested in seeing what my final count looks like, right? So let's do one final SOP outside the while loop to see, say, you bought I lottery tickets. Oh, we called it count. So, yep. Okay, if you really want to make it tragic, you take this, multiply it by the cost of the lottery ticket and put it in terms of dollars, like you spent this amount of money, and that has a little bit more of an impact. So let's try this again. I'm still going to go with 3 numbers. Oh, that's fast, right? In that amount of time, we did 84,000 lottery tickets just to find a winner, and that's with only 3 numbers. Okay, and again, printing takes up a lot of time. So once you kind of verify that things work, you can kind of take this out, and what you're going to end up with is a program that executes extremely fast, right? We did way more lottery tickets in order to find our winner. I'm going to try it again. Right? That should give you an indication of like how much time printing actually takes up. Okay? So with that in mind, I would test maybe going to 4 lottery tickets. I don't actually know like how long this would take. I'm hoping pretty fast because we like churned through this, but as you can imagine, oof. Okay. And last one I'm going to try to do here is 5. I can go ahead and tell you, I don't think this would finish on video. And I'm not going to put you through that agony, but hopefully you have created this program, you've replicated what I've done here, and you can test this. And hopefully you'll recognize that getting a winning lottery ticket, even when there's only 60 possible numbers, 1 through 59, even there's only 5 of them, getting a winning lottery ticket, extremely hard. Don't do it. Save your money. I'll see you in the next one.